Extraction of iron. And iron is the second most commonly naturally occurring metal. It makes about 4% of the Earth's crust. It exists as hematite, which is iron 3 oxide, magnetite, and siderite. Iron is extracted by use of a blast furnace. It being a less reactive metal, it cannot be extracted by electrolysis process, therefore we use the reduction. And as earlier mentioned, we are saying that the reduction here we can either use carbon or carbon 2 oxide gas. In the blast furnace, the raw material used are either hematite, magnetite, siderite, coke, which is mainly carbon, and limestone, which is calcium carbonate. Iron is usually extracted from the main ores, which we've already mentioned being hematite, magnetite, or siderite. These ores contain silicon 4 oxide and aluminium 3 oxide as impurities. When extracted from siderite, the ore must first be roasted in air to decompose the iron 2 carbonate to iron 2 oxide with production of carbon 4 oxide gas. Iron 2 oxide is then rapidly oxidized by air to iron 3 oxide, as you can see from these equations. So this is the roasting of iron 2 carbonate to form iron 2 oxide, and later on oxidizing iron 2 oxide to form iron 3 oxide. Hematite, magnetite, coke, and limestone are all then fed from the top of the blast furnace, and a blast furnace is about 30 meters in height, a tapered steel chamber lined with refractory bricks called the blast furnace. The furnace is covered with inverted double cape to prevent amount of any gases escaping. And in so doing, we also minimize the amount of heat lost. Near the base of the blast furnace, hot air at about 827 degrees Celsius is driven into the furnace through small holes called tires. As the air enters, it reacts with the coke, which is carbon, to form carbon 4 oxide gas. This reaction is highly exothermic, producing a lot of heat. So the equation is that carbon plus oxygen to form carbon 4 oxide. This raises the temperature at the bottom of the furnace to about 1650 degrees Celsius. As carbon 4 oxide gas rises up the furnace, it reacts with more coke to form carbon 2 oxide gas. This reaction is endothermic, and that's why you can see the sign is positive. Carbon 2 oxide gas is a strong reducing agent that reduces the ores at the upper parts of the furnace, where temperatures are about 500 degrees Celsius. For hematite, iron 3 oxide reacts with carbon 2 oxide to form iron, and for the magnetite, it reacts also with carbon 2 oxide to form iron. So those are the respective equations. Iron being denser than iron ore, it falls to the hotter base of the furnace, it melts and can easily be tapped off. Limestone fed in the furnace decomposes to form calcium oxide and produce more carbon 4 oxide gas. As then from the earlier processes, the carbon 4 oxide reacts with carbon to form carbon 2 oxide that is used as a reducing agent. Then the quicklime or the calcium oxide reacts with the impurities of the ore, which are silicon 4 oxide and aluminium oxide, to form calcium silicate and calcium aluminate. Calcium silicate and calcium aluminate mixture is called slag. Slag is denser than iron ore but less dense than iron. Therefore, it floats on the pure iron. It is tapped at different levels. Just its tap is slightly above the tap of the iron. The, the slag formed is used in the tarmacking of roads, cement manufacture, and as also a construction material in the building industries. Uses of iron. Iron obtained from the blast furnace is hard and brittle. It is called pig iron. It is remelted, added scrap steel, then cooled. This iron is called cast iron. Iron is mainly used to make gates, pipes, engine blocks, rails, charcoal iron boxes, lamp posts because it is cheap. Then it is also used to make nails, cutlery, scissors, sinks, vats, spanners, steel rods, and railway points from steel. It is also used as an alloy, which is mixed with the carbon, manganese, chromium, and it is used this way because it does not rust like normal iron. This is the diagram showing how the blast furnace looks like, and this is what we are saying. We have the inverted double cap to prevent heat loss and also to prevent the escaping of any gases into the atmosphere. Then this is the lining of the blast, which I see that it is a tapered lined with the refractory bricks all through the blast furnace. Then we have the small holes that we are calling the tires, where heat is supplied in the furnace. Then iron being very dense, it falls on the bottom of the blast furnace and it is tapped off as the pig iron. Then slag being just relatively more slightly less dense than iron, it floats on the surface of iron and is tapped off as slag. And these are the equations that are taking place at all the points of the blast furnace. So kindly you have to remember to get all these equations because they are very important and they explain whatever is taking place. So that is what we have for extraction of iron. Then you can get more questions and more reading from your books.
It has been since 5,000 years that man is using iron. Iron is the second most abundant metal in the earth. The most important ores of iron are hematite and magnetite. These ores contain different types of impurities. The first step is to remove the impurities. This is called as concentration of the ore. The iron ore is converted to iron in a blast furnace. This is made of steel in which the inner side is covered using bricks. The mixture of concentrated ore, coke, and limestone are added from the top into the blast furnace. A powerful current of hot air is blown from the bottom simultaneously. During the flow of hot air from bottom to top, coke combines with oxygen in the air to form carbon monoxide. 2C on reaction with O2 forms 2CO. Due to this reaction, a large amount of heat is released, and thus the temperature of blast furnace increases to 2000 degrees Celsius. Carbon monoxide formed in the furnace reduces the ore. Fa2O3 on reaction with 3CO forms 2Fe and 3CO2. At high temperature, calcium carbonate decomposes to form calcium oxide and carbon dioxide. CaCO3 forms CaO and CO2. Then impurity silicon dioxide in the ore reacts with calcium oxide and form calcium silicate, which is known as slag. Flax on reaction with gas forms slag. CaO on reaction with SiO2 forms CaSiO3. The iron obtained directly from blast furnace is called as pig iron. It contains carbon, sulfur, phosphorus, manganese, silicon, etc. in very small quantities. Pig iron is heated to melting and again solidified to get cast iron. In cast iron, 95% is iron. The iron which contains 0.1% to 1.5% of carbon is called steel.